Welcome back to my channel. In today's lecture, we are going to solve some other questions regarding kinematics. In this video, I will show you some questions and you have to solve by yourself and then compare your solution with my solution. So before wasting any time, let's start with question number one. An airliner must reach a speed of 110 meter per second to take off. If the available length of the runway is 2.4 km and the aircraft accelerates uniformly from rest at one end, what minimum acceleration must be available if it is to take off? Now, we have to identify which variable is given to you and what is question is asking for. By doing this, you can easily identify the unknown variable and the known variables. And then you can put the equations and put values on it. And you will get the answer. So in solution, we have a final velocity which is 110 meter per second and airliner is taken from rest. So initial velocity is 0 meter per second. Now it covers the distance about 2.4 kilometer. Here we have a speed in meter per second and in distance in kilometer. So it should be the same unit. So we have to convert kilometer in the meter by multiply by 1000. So we got the distance in meter which is 2400. Now use this equation. In this equation we know what is the V, U and S and we have to find A. So put the values over here and you will get the answer 2.52 meter per second square. This is about question number one. Question number two says a speeding motorist passes a traffic police officer to stationary motorcycle. The police officer immediately gives chase. His uniform acceleration is 4 meter per second square. And by the time he draws level with the motorist, he is traveling at 30 meter per second. How long does it take for the police officer to catch the car? The second question is if the car continues to travel at steady speed during the chase, what is that speed? So in this question, the motorist means that the who drives the car, okay, like a driver, okay. So in this question, there are two questions. In this question number two means first is how long does it take for the police officer to catch the car, means time. Second question says if the car continues to travel at a steady speed during the chase. So you have to find a speed also. So try by yourself. So the solution over here is first is time to catch the driver or motorist. So initial speed is 0. Now the car is going 30 meter per second. So the police officer should be the same speed, means V is equal to 30 meter per second. And by changing this velocity 0 to 30 meter per second, it should be need some acceleration, which is here is 4 meter per second square. Now we use this equation over here because we know V, U, and A, and we need to find T. So T is 7.5 seconds. After this time, the police officer catch the motorist. Now we need to find the distance. Okay, so distance is covered by the police officer during this time. So which is ut plus half at square. So TO we got here, U is 0 and A is given to you. So the S over here is 112.5 meter. So this is about question number 2. Question number 3 says a cricket ball is thrown vertically upwards with a speed of 15 meter per second. What is its velocity when it first passes through a point 8 meter above the cricketer's head? So ball over here is going upward direction, vertically upward direction with speed of 15 meter per second. So we need to find what is its velocity when first passes through the point 8 meter above a cricketer's hand. Means cricket is standing over here and the 8 meter like this is the distance. So try by yourself. Now the solution we have initial velocity given us in the question is 50 meter per second. Height 8 meter. Now the acceleration they didn't mention over here about the acceleration. So this whole process is come under the gravity. So we need to consider over here a gravity, which is in towards the earth, means downward, vertically downward. So if you take initial velocity, which is going vertically upward, take as a positive, and the downward side take negative. So here I mentioned the acceleration over here as a negative value. So take upward is a positive, downward as a negative. I hope you clear this sign conversion. So we need uh, velocity, final velocity, I would say. So the taking upward direction as a positive, okay? I can write here. V square is equal to u square plus 2as. I use this equation because I need this v. I know what is u, a, and s. So put these values from this data over here, and you will get the answer like 8.25 meter per second. This is a positive because it is upward velocity. Okay. In this particular question, we taken as upward direction as a positive and downward direction as a negative. We can also do like upward direction negative and downward direction is a positive. Okay, by doing this, the question answer is remaining the same, but you have to mention over here in which direction. Okay, I hope you get the question number 3. Now we move next on question number 4. In question number 4, a stone is thrown from the top of the vertical cliff. Here, figure 2.26, you can see over here the vertical cliff of 45 meter. The person or object is over here, the 45-meter height above ground level with initial velocity is 15 meters per second. There is a mention over here, the initial velocity of an object is 15 meters per second in a horizontal direction. Okay, so you have to clear the what is velocity over here is a horizontal direction. Okay, now question is how long does it take to reach the ground? Okay, means time. And another question is how far from the base of the cliff is it when it reaches its ground? Okay, means we need to find this value as well. Okay, so yes, hint is using equation of motion. Okay, now what is the solution over here? The solution is uy. Here I have to mention the coordinate axis because there is a 2D motion over here. So let's suppose I have taken this as x-axis, means this is the x, and this is the y-axis. Okay, so uy is zero because there is no initial velocity of vertical direction. Here in question, they mention about the horizontal direction only. So the y means the vertical height is 45 meter. Now we have to need to find that what is t over here, the time to take this object to place on this surface. So we have this equation which is only depend on y direction regarding to y. So y is equal to uy t plus half at square. E is a constant over here because a is g means is the gravity, okay, which is always downward direction. I hope you keep in mind. So we have y, put this value over here. Uy is equal to 0, initial velocity in the vertical direction. Okay, we need to find t. So this is going to end 0 because uy is 0. Half it square is equal to y. Okay, and you will get the answer 3 seconds. Now, in the second questions, means we need to find the, what is the range over here, means what is the distance over here in the x direction. So in this case, we consider the in the x direction velocities. Now, in the question, we have given that the horizontal direction speed, initial speed is 15 meters per second. So we use this over here, and the time is the same as we find earlier. It is 3, it's 45 meter. So this is the question number 4. I hope you understand this concept because this is a kind of a projectile motion idea. Okay, this is a 2D motion. So you have to describe this motion in two way. In first in x direction and second one is y direction. Okay. Question number 5 says an electron traveling with velocity of 2 into 10 to 7 meters per second in a horizontal direction. Okay, enters a uniform electric field. This field gives the electron a constant acceleration, they mentioned over here, and they give a value over here like this in a direction perpendicular to its original velocity. Okay, we have to refer the diagram figure 2.27. The field extends for a horizontal distance of 16 millimeter. What is its magnitude and the direction of the velocity of electron when it leaves the field? Okay, first we have to understand what is a diagram over here, which is a electron is entering through this electric field region, and it is band like this. Okay, and the gap between over here is 16 millimeter at the initial horizontal velocity. Okay, in this question, we have to also consider the coordinate system, I would say, means x and y. You can take as like this, or uh, you can like this also. But according to the standard notation, we use this kind of coordinate system. So try to figure out what is the answer over here. Now the solution time. We know the horizon we I defined like this. So the horizontal direction initial speed is like this 2 into 10 to 7 meter per second. And the gap over here is about 60 millimeter. So we need to find t over here. How much take time means the simple formula I use over here, distance upon taken time, and I got the answer 3 into 10 to minus 9 second. Now, when the electron enters the electric field, they didn't mention about the uh, vertical direction. So we need to consider as a zero. Okay. And in this figure, also they show in the only x direction. There's no component of y direction. So we use this equation over here. Vy is equal to 0. We need to find Vy. So Vy we got here. We need to find T over here because we need T in this equation. So the question arises in mind that why we need to find T. There is no mention over here to find T because we need to find T using in this equation. Okay, we here find Vy. Okay, I hope your concept is clear about question number 5. Now, question number 6 says a ball is thrown horizontally from the top of the tower of 30-meter height. Here in this figure shows the 30-meter height tower and lands 50 meters from the base. Okay, they did also mention the horizontal distance 15 meter. What its ball's initial speed? Okay, so try to figure out and what is the possible answer. Now here I write what is the given data over here. Height of the tower is 30 meter. Horizontal distance is 50 meter. Now they didn't mention about the gravity, acceleration. So in those cases, we need to consider G. Okay. The initial vertical velocity is Uy is 0. Why? There's only a horizontal component. There's no vertical component over here. Okay. So we taken as Vy is 0 and this is clear about Ux. Okay. So we have to find the initial speed. But first, we need to find the time taken to object ball to take this height to this lower 15 meter, cover that 15-meter distance. So we use this equation. It's all about in the y component. So h is for the y 30 meter. Do not use over here 15 meter because we use here on the vertical component. I would say a y components. So Uy initial velocity is 0, so it should be 0. Half gt square. G is always there. Okay, 9.8, and you will get the answer T, 2.473 seconds. So it is time to take the ball is from this position to this position. So last we need to find the horizontal distance. Sorry, it is the initial velocity. So we use this equation. Velocity is distance upon time. So we need a velocity over here. We have a x means 15 meter. They given us 15 meter at the time, which is already we got here. So put this value and you got the answer about 6.06 meter per second. So this is also questions of a 2D motion. In this kind of question, you need to separate the x variables and y variables. Only after you doing this, you can easily solve this kind of question. Okay. Question number 7 says a football is kicked on the level ground at the velocity of 15 meters per second at angle of 30 degree. Okay. Now we have to find the s. Okay. Here the solution is initial velocity is 50 meters per second, launch angle is 30 degree, and the acceleration is about 9.8 meters per second square. So the we know all know the range formula. It is u square initial velocity square sine 2 theta. Theta is the launching angle at which at the angle at which the object is throw a launching. Okay, and g is gravity. So put all this value over here, and you will get the answer about 19.86 meter. Okay, this is a very easy question, I would say, because if you know this formula, you can easily put all the values over here. Number 8 says car accelerates from 8 meter per second to 20 meter per second in 6 seconds, assuming uniform acceleration. It means you are allowed to use equation of motion over here, the three equation of motion over here. Use the equation which is fits over here. Okay, so how far does it travel in this time? Okay, so we need to find s. We have got u, v, t. So which equation we are using? Try to recall it, use it, and got the answer, and try to match with my answer. So the solution is I write here u, v, t. First, I use this equation. We have v, u, we don't have a. So we need to find first a. Here we find a over here. And then we use this equation, means this v square is equal to u square is equal to 2as. In this equation, we know a, u, v, and we got s easily, and you got s. Okay? In this type of question, you need to identify first the which variable are given to you. Okay? And which given they are asking for. So once you understand this, you will easily understand the concept behind it. And if you know these equations, okay, so keep three equation of motion in your mind, okay, while you're doing the kinematics. In question number 9, if a raindrop were a fall from a height of 1 kilometer, means the drop is falling in 1 kilometer, with what velocity would it hit the ground if there were no resistance over here? So they given us S, G will know, all know. We need a velocity, the time at which it is hit the ground. So initial velocity, we can first raindrop is at rest, and then it steadily gains some velocity due to the gravity. So we use this equation. In this equation, we know U, V, A is always there, means G. It is a kind, you can say, it is a cause of uh, U is equal to 0 to V. Okay, the change in velocity is caused by gravity. I would say acceleration, somewhat of acceleration. And you know the S over here is 1 kilometer, but you have to convert in meter, 1000 meter. So put these values over here, and you will get the answer about final velocity, I would say 140 meter per second. So this is also a simple question, I would say. Number 10 says a traffic police can estimate the speed of the vehicle involved in accidents by the length of the marks made by the skidding tires on the road surfaces. It is known that the maximum deceleration that a car can attain when braking on the normal road surface, about 9 meter per second square. Here, they didn't mention clearly what is it, but from the unit, we can say it is somewhat of acceleration because the unit is meter per second square, means 9 meter per second square. Okay, how you identify the variables when they didn't mention directly. So this is a one method to identify some kind of variables over here. So in one accident, the tire marks were found to be 125-meter long. Estimate the speed of the vehicle before braking. So this is a kind of a stopping distance concept, I would say. So try by yourself. Now the solution is the some car is going uh, with velocity u. After some time, it will stop. Means final velocity is zero. Consider those scenario in your mind, and this will help you to identify the variable and the expected values of the variables. So A is minus 9.8 meter per second square. Why? So sorry, this is a 9 meter per second square. Why? The car is going to some uniform velocity, and it is going to stop. So it is a negative acceleration. You have to do a brake on the car. So it cover a distance before stop. It is about 125 meter. So use these equations and you will get the answer U. What's the initial speed of those car? It's 47.4 meter per second. They didn't mention over here in which unit they need. So try stop here. Otherwise, they will mention that they need the answer in kilometer per hour. So you have to just do 18 upon 5 multiply by with this quantity. Okay. I hope this question is very useful to you. Okay. I hope you can easily solve these 10 questions and you will get the concept behind it. And I would say this is a very simple question. Once you are doing this question by yourself and regularly practicing it, and then you can easily solve any kind of questions of unit 2 kinematics. So this is all about this video, and in my next video we will solve some other questions like graph questions. So keep practicing, keep doing reading concepts. And one more thing I have to add means uh, use this concept in your regular life. If you consider as you are if you are doing in the regular life, so you can easily uh, remember the three formula which is I given to you. It's an equation of motion and another concept of projectile motion. So try to connect this these things in your day-to-day life. Okay, so thank you for watching. Subscribe for more physics lectures.